Okay, here we have a nasty little beastie, a cosecant equation, which is a reciprocal equation. Okay, so that's going to be one thing to watch out for. And it's also a fourth order equation. Okay, there's an exponent of 4 in there. So we've got a bunch of things here to sort out. First of which, well, I guess we'll deal with reciprocal last. Treat it like it's a normal equation. You've got a trig function. Okay, that's all you need to worry about. And one nice thing is it's the same trig function everywhere. So I would recommend a U-substitution in this guy. Let's see what kind of U-substitution we can make. I'm going to say, I don't know, U equals cosecant omega. And if you make U equals cosecant omega, this becomes U to the fourth minus U squared minus 2 equals 0. Well, okay, I don't know how much progress this is for us. It's kind of hard to solve fourth order equations by factoring. If you want to pull in some kind of crazy rational roots, you can. I would recommend actually making a different U-substitution. And you might notice a pattern here, 4 and 2. Okay, those are a factor of 2 apart from each other, which lets you do this little trick. What if my U-substitution was cosecant squared? Well, the middle one, the middle term, is just going to be U, right? U is cosecant squared. Whereas cosecant to the fourth, that's going to be U squared. Okay, so now my equation is U squared minus U minus 2 equals 0. And that looks quite nice. We can factor this easily. This becomes U minus 2 times U plus 1 equals 0. Okay, and double check your factoring, make sure that's okay. So now we can move on and say what our solutions are. U equals 2 and negative 1. And now we make that substitution in reverse. We say, we don't really want U, we want cosecant squared. So cosecant squared of omega equals 2, and cosecant squared of omega equals negative 1. And I'm actually going to be working with 2 for the most part, so let's move that down here. Now, cosecant squared equals negative 1. The problem with that is you try to square root each side, and we get imaginary. Get imaginary solutions for this one. So that means this part is going nowhere. Okay, you can cross that out. All we have left is this guy, cosecant squared equals 2. So let's clean this up a little bit. Cosecant squared equals 2. What does that give me? Well, that gives me cosecant of omega equals plus or minus. Remember, it has to be plus or minus because I'm square rooting both sides. Plus or minus the square root of 2. And now once you have isolated the cosecant term, you're ready to turn it into a sine term. Remember the reciprocal identity. Cosecant equals 1 over sine. So that means sine of omega equals plus or minus 1 divided by radical 2, which you may recognize this way. 1 over radical 2 is the same as radical 2 over 2. And that's on the unit circle. That's something I can point to. Let's see where it is. Here's my unit circle. Now, radical 2 over 2 in the y-coordinate is this special point right here. So there are the positives, radical 2 over 2. And here are the negatives, radical 2 over 2. So what are these angles? That's the question. Those are our solutions. In quadrant 1, we get pi over 4. In quadrant 2, we get 3 pi over 4. In quadrant 3, 5 pi over 4. And in quadrant 4, we get 7 pi over 4. This is it. Those are our solutions to the equation. So along the way, here are the important steps. First, step 1, don't freak out when you see a fourth order. I'm only going to throw fourth orders at you when it's possible to make a U-substitution and simplify that down. Factoring is our go-to tool. When you find something that's a domain restriction, just cross it out, move on. And then when you have a reciprocal, like right here, remember to flip that over into a trig function that you're more familiar with, like sine.